Now, of course, rescue efforts are continuing today in Myanmar following that powerful 7.7 magnitude earthquake that struck the country and neighbouring Thailand on Friday. More than 1,600 people at least have been killed so far. That's what's known. Thousands more have been injured in the disaster too. Joining me now to talk about this is Anastasios Sextos, who's a professor of earthquake engineering at Bristol University. Professor, good to see you. Thanks for joining us here on Sky News this morning. When it comes to earthquake engineering in this part of the world, how prepared were these countries?
Good morning, Matt. First, let me convey my condolences and support to the people who are suffering in Myanmar. Coming to your question, these countries, the preparedness around the globe is essentially analogous to the level of financial development, unfortunately. This is a social problem that relates very much to what the local authorities can do in advance of such events. And therefore, in countries like Myanmar, obviously the quality of construction and perhaps the level of preparedness is not, let's say, comparable to what we would observe in, let's say, in California or in Japan.
Yes. Clearly, there are still buildings standing, but that doesn't necessarily mean they're safe, does it?
Well, not necessarily at all, because after such a strong earthquake, they may have exhausted their capacity to resist further seismic forces. And we know very well that such a strong earthquake event will be followed by very strong aftershocks. If the main shock was 7.7 magnitude, there was an aftershock that was around 6.7, and there are going to be more and more aftershocks for months. So clearly, they are not safe to be used.
And in terms of the magnitude of this quake, where does it rank compared to other quakes that have hit this part of the world?
Well, Myanmar is a highly seismic zone. So earthquakes of the same or similar magnitude have happened like 6 times in the last 100 years. So this is not uncommon. The problem, like we discussed in this region, is that buildings have not necessarily been designed to modern seismic codes, and therefore their seismic capacity is not enough to resist such strong earthquake forces.
When it comes to the other infrastructure, Professor, that's also presenting real problems. Communications weren't exactly a global standard in Myanmar before this, but now that's proving a real problem for aid agencies.
This is a huge problem because, as you know, Myanmar is a country that is experiencing, let us say, a degree of political instability, if I might put it this way. So essentially the rescue operations, first of all, but all the recovery plan and the crisis management is very hard to proceed. Also, there is the factor of the US aid that flows, let's say, at a slower pace, as you know very well, with the new US administration, that has affected many countries of low income. Therefore, we have a major physical problem, a natural disaster, but at the same time, we have administrative difficulties for the help to reach out.
Yes, we were hearing exactly the same thing from the International Rescue Committee, a prominent NGO earlier on, although they did say it was too early to read the impact or lack of US AID. Professor, just to finish off on the science of this, given that that is your area of expertise, when there is such a large quake as this, are there always lessons to be learned? Do they always throw up something new to understand or not?
That's an excellent question, Matt. And in fact, science progresses by the field observations, clearly. But I'm afraid I have to say that the main lessons have already been learned. And out of these lessons, the most important it is that seismic safety is essentially depends very much to the degree of preparedness, which, as I said, is a function of the status of each specific region around the globe. So it's not necessarily a scientific problem. Scientifically, we are in position now to construct and design safe structures that don't collapse. They may be damaged, but in a smart way. The problem is that around 2/3 of the buildings in these regions are substandard, and therefore they're very, very vulnerable to future events.
Professor Anastasios Sextos of Bristol University, appreciate you joining us. Thank you very much indeed.
Thank you, Matt.